For question 4 of the 2016 Practice FRQ, you have to find a particular solution given an initial condition. So we start off by separating the variables, and remember that if we were to multiply both sides by dx, so that those can cancel out, and then divide both sides by y minus 2. Looks a little messy up here, but you should have 1 over y minus 2 dy equals x squared plus 1 dx. So we've successfully separated the variables. All y variables are with dy, and all x variables are with dx. And we're going to integrate both sides. Remember that 1 over y minus 2, it's just the natural log of y minus 2. Hopefully this isn't too hard to see. It's just a simple u substitution. If you let u equal y minus 2, then you have the integral of 1 over u. Notice that when you do du with respect to y, you get 1. So du and dy are equal to each other, so that's just, we just easily change our dy to du, and that's just simply the natural log of u. And then we can just resubstitute the y minus 2 back in to get ln of the absolute value of y minus 2. On the right side, we just get x cubed over 3 plus x plus c. Okay, and this is an equal sign right here. And what I'm going to do now is I'm going to raise both to the base e, so that the e and the natural log will cancel out, and we're left with. So this right side here, what we can pretty much do is just, this is just e to the, and I'm looking at this part here, that's just e to the x cubed over 3 times e to the x times e to the c. And I just want to remind you that e to the c is just pretty much c. So what we get is this. And so I just pretty much left e to the x cubed over 3 plus x kind of together rather than separating them like this. I just did this step to show you that this is going to, e to the c is going to be just c. I'm going to use my initial condition to solve for c. So to solve for c, you got to remember that the initial condition g of 0 is equal to 5 pretty much means that x equals 0 and y equals 5. So you just plug those values in. For y, I plugged in 5. For x, I plugged in 0. And then just do the math, solve for c. We get the absolute value of, this is going to be 3. 5 minus 2 is 3, and the absolute value of 3 is just 3, equals c. And then 0 cubed is 0. 0 over 3 is 0. So 0 plus 0 is 0, so we get c e to the 0, which is just 1, so c is equal to 3. So what I pretty much do is that c equals to 3, I now have the absolute value of y minus 2 equals 3 times e to the x cubed over 3 plus x. And now what I'm going to do is I'm going to go ahead and solve for y. And a quick reminder that to remove these absolute value bars, we just pretty much put plus or minus. So we have y minus 2 is equal to plus or minus 3 e to the x cubed over 3 plus x. We're almost done. I'm going to add 2 to both sides. So we have this. And we're still not quite done. We can't leave the plus or minus here. So we cannot leave the plus or minus there. We're going to use our initial condition to see whether this should be a plus or minus. So we have to put the 5 for y and the 0 for x. And it's not really too bad. All we have to do is, once you've plugged in your 5 for y and your 0 for x, or whatever your initial condition might be in your problem. In this case, it's y equals 5, x equals 0. That should be a 0. We're just going to do the math. Just go ahead and do the math. So we get 5 equals plus or minus. We already did this. This is going to be e to the 0. And it's just going to be 1. So we get 3 times 1. And then we bring down the plus 2. So what does that 3 have to be in order for this to be true? Well, if we choose negative 3, if we choose the minus, it's going to be negative 3 plus 2, which will be negative 1. This will not be true. So it has to be the positive 3. Okay, so that tells us that we have to choose positive 3. So our final answer is y equals positive 3 e to the x cubed over 3 plus x plus 2. And that's the answer. Now, one thing that I want you guys to notice is that I stopped using equal signs earlier on. So be careful with your equal signs. It's actually probably better if you don't put equal signs, because the minute you put equal signs, everything has to be equivalent. And if it's not equivalent, if you make a mistake and it's not equivalent, you then get points taken off on the AP test. So it's actually recommended not to use equal signs, or don't go equal sign crazy. Don't start putting everything equal to each other, because if you get too carried away with equal signs and there's something that's not equivalent, then you get points taken off. Okay? Okay, so for part B, you have to find the limit as x approaches negative infinity of g of x, and g of x is the function you found in part A. So what you're being asked is pretty much that. Now, remember that it's a limit, so your first thing should be do the direct substitution. So negative infinity. This isn't too bad, because this is pretty much going to go to negative infinity. Okay, so what we have is negative infinity cubed is just negative infinity over 3 plus negative infinity. Okay, negative infinity cubed is just going to negative infinity faster. You want to look at this as 1/3 negative infinity plus negative infinity. That 1/3 times negative infinity, that 1/3 pretty much plays no effect on it. It's still going to negative infinity. Negative infinity plus negative infinity is just negative infinity. So this thing is just it's approaching negative infinity. So I can rewrite this as 3 e to the negative infinity plus 2, or 3 over e to the positive infinity plus 2. Now, one thing that you need to know is that, well, before I bring that up, I want to make sure that you know that e to the infinity is just infinity. Okay, so what we have here is 3 over infinity. So we have 3 over infinity plus 2. And In a fraction like this, when the denominator is getting bigger, this thing is getting closer and closer to 0. So 3 over infinity is just 0, and we have 0 plus 2 is just 2. That's your answer. So real quick, to sum it all up, we pretty much did that the limit as x approaches negative infinity of this g of x function. We just did direct substitution, and we found that exponent it all approached negative infinity. So 3 e to the negative infinity plus 2 is what we got, but then we changed that to 3 over e to the infinity. E to the infinity is just infinity, so we have 3 over infinity plus 2. And then 3 over infinity gets closer and closer to 0, so 3 over infinity is 0. We get 0 plus 2, and we just get 2 as our final answer. For part C, we had to find the second derivative, d squared y over dx squared, so that's the second derivative, and it's with the initial condition of f of 1 is equal to 3. We are then supposed to determine whether the graph of y equals f of x is concave up or concave down based on that second derivative. So we have to start with what is given to us, and that's pretty much dy over dx equals y minus 2 times x squared plus 1. Remember, this is a product, therefore we have to use the product rule when calculating the second derivative. So d squared y over dx is equal to y minus 2 prime times x squared plus 1 plus y minus 2 times x squared plus 1 prime. And when we do y minus 2 prime, it's just 1, but don't forget that we are with respect to x, so the derivative of y minus 2 is 1 times dy dx. Okay, and then bring down the rest, and the derivative of x squared plus 1 is just 2x. This one we don't have to multiply by dy over dx because we are differentiating with respect to x, and the variables are x, so it matches up nicely. Now the trick here is that dy over dx, we know what dy over dx, it's what was pretty much given to us at the beginning, so I'm going to go ahead and replace that with this. So this is what we get. Now we're ready to input our initial condition of f of 1 equals 3. Don't forget that that pretty much implies that x equals 1, y equals 3. So let's plug that in. This is what we pretty much get, and we are ready to just do the math. And we get, this is 1, this is going to be 2, this is going to be 2, this is going to be 1, and this is going to be 2. So d squared y over dx is equal to 6, because 1 times 2 times 2 is 4, plus 1 times 2 is 2, so 4 plus 2 is 6. Now we got to answer whether it's concave up or concave down, and this is real easy because this came out to positive 6, so when the second derivative is positive, the function is concave up. Okay, so in this case, it's going to be concave up because this second derivative came out to be positive. So make sure that you include that in your explanation. And just stating that the graph of y equals f of x is concave up because the second derivative d squared y over dx is greater than 0 will be fine. That'll give you the full credit. And that's it.